Number 49A is a Wille precipitate form. We're told that we have 0.050 molar calcium chloride and that we are going to adjust the pH to equal 8. Now 8 is basic, so 8 means that there's going to be hydroxide ions. And just like in one of the previous examples, we know that POH will equal 6 and that the concentration of hydroxide is going to equal 1 times 10 to the minus 6. So the question is, with this much calcium, 0.050, calcium ions, and this much hydroxide ions, will a precipitate form? Will it back up and make the solid? So, and we know that our KSP expression is concentration of calcium ions times concentration of hydroxide ions squared. So we need to just put these in. This will be Q because it's not at equilibrium, and it will equal 0.050. That's the calcium ion because it's one of these ions for every one of these that breaks up, and that'll be times the concentration of hydroxide squared. So Q is going to turn out to be 5 times 10 to the minus 14. From the table, I find out that KSP is 6.5 times 10 to the minus 6. So Q is clearly much smaller than K. Q is less than K. So no precipitate will form. In part B, it's another Wille precipitate form. This time it is about silver sulfate. So we have silver ions and sulfate ions going together, and our KSP is silver ions squared times sulfate ions. So given our initial conditions, we have to find what's the concentration of silver ions, and that's going to equal the original concentration times the original volume divided by the total volume. And for silver, that works out to be 4.54 times 10 to the minus 2. For sulfate, that equals its original concentration times its original volume divided by the total volume. And that also ends up equaling 4.54, but this times 10 to the minus 3. And these are both molarities. So Q equals the concentration of silver squared times the concentration of sulfate. And Q equals 9.4 times 10 to the minus 6. KSP for silver sulfate equals 1.5 times 10 to the minus 5. So once again, Q is less than K, no precipitate forms.